Hello students, today we are going to solve page 120, number 10. Let ABC be an isosceles triangle of vertex A. The perpendicular at A to AB cuts BC at M. When we draw the perpendicular to AB at A, it will cut BC at M, so we keep on extending the perpendicular and BC until they meet at point M. The perpendicular at A to AC cuts BC at N. So we draw the perpendicular to AC. Then we keep on extending the perpendicular and BC until they meet at point N. Show that the two triangles ANC and ABM are congruent. Then deduce BM equals CM. So part 1 and question 1, show ANC and ABM are congruent. So this is triangle ANC in yellow, and we have the triangle ABM in green. So let's find the three evidence needed to prove that they are congruent. Let's see if they have a common side here. Is BC a common side? They look that they are glued at BC, but we notice that the letters B and C are not repeated in their names. So no, it's not a common side. It's part of the sides CN and BM in both triangles, so be careful. Now looking at the information given in the text of the exercise, since ABC is isosceles of vertex A, we can claim that the side AC in triangle ANC is equal to side AB in triangle ABM, because these two sides are the legs of this isosceles triangle ABC of vertex A. Now let's prove that the angles adjacent to AB and AC are respectively equal. In fact, angle ACN is the same as angle ACB, and angle ABM is the same as angle ABC, or angle ACB and angle ABC are equal because they represent the base angles of this isosceles triangle ABC of vertex A. That's why we can claim that angle ACN is equal to angle ABM. Now all we need to do is to prove that the angle of vertex A in triangle ANC is equal to angle of vertex A in triangle ABM. But here, since AN is perpendicular to AC, we can claim that angle CAN equals 90 degrees. And since AM is perpendicular to AB, we can claim that angle BAM is equal to 90 degrees. So we found our third evidence. These two angles are equal to 90 degrees each. Now let's write the proof. So first, in triangles ANC and ABM, AC equals AB, legs of isosceles triangle ABC of vertex A are equal. Then angle ACN equals angle ABM, base angles of isosceles triangle ABC of vertex A are equal. And last, CAN equals angle BAM equals 90 degrees. It's given. They placed the codes here on the figure, or perpendicular effect. Now the congruence statement, triangles ANC and ABM are congruent by one equal side included between two equal angles. Now part 2 in question 1, deduce BM equals CN question mark. Here we notice that side BM is in fact a side of triangle ABM, and segment CN is in fact a side of triangle ACN, which we just proved that they are congruent. So as a result, these two segments are equal because they represent corresponding elements of these two congruent triangles. Proof: triangles ANC and ABM are congruent, so all their corresponding elements must be equal, namely or in particular BM equals CN. Question 2. Compare the two triangles ABN and ACM, then deduce that triangle AMN is an isosceles triangle. So let's start with the first part, compare triangles ABN and ACM. When we say compare two triangles, it means are they congruent? Let's see. So ABN is this yellow triangle and ACM is this green triangle. Let's see if they are congruent. First here, we can easily see that AB is equal to AC. So we found two equal sides. Let's see if we can prove that the angles adjacent to side AB in triangle ABM, it means of vertex A and B, are equal to the angles adjacent to side AC. It means the angles of vertex A and C in triangle ACM, if they are respectively equal. Here, since angle CAN is a right angle, we can claim that angle BAN and BAC are two complementary angles. It means BAN is the complement of angle BAC. And since angle BAM is a right angle, we can claim that angles CAM and BAC are also complementary angles. So CAM is the complement of angle BAC also. So here these two angles are the complements of a same angle. That's why they are equal. So BAN equals CAM because they are the complements of the same angle BAC. Now let's prove that angle BABN is equal to angle ACM. In fact, angles ABN and ABC are in fact supplementary angles. So angle ABN is the supplement of angle ABC. And here also angle ACM and angle ACB are two supplementary angles. So angle ACM is the supplement of angle ACB. But since angle ABC and ACB are equal because they are the base angles of this isosceles triangle ABC, their supplements also they are equal because supplements of equal angles are equal. We found our three evidence. Now let's write the proof. Proof. In triangle ABN and ACM, first we have AB equals AC, legs of isosceles triangle ABC of vertex A are equal, or you can also write proved because we proved it here already. Then angle BAN equals angle CAM because they both represent the complement of the same angle ABC. Complement of the same angle BAC are equal. And last, angle ABN equals angle ACM because they are both the supplements of these two equal angles ABC and ACB. angle ABN equals angle ACM because they both represent supplements of equal angles ABC and ACB, and they must be equal. So here we don't have to prove that these two angles ABC and ACB are equal because we already proved it here, because they represent the base angles of this isosceles triangle. But in case we don't know that these two angles are equal and we can prove it, we should prove it earlier before we claim this evidence. So be careful. Now the congruence statement. Triangles AB and ACM are congruent. Equal, it means congruent by one equal side included between two equal angles. Part 2, deduce that AMN is an isosceles triangle. Deduce AMN is an isosceles triangle. To prove that a triangle is isosceles, we need to prove either that it has two equal sides or that it has two equal angles. Can we claim that AN equals AM? Let's see. Since we proved in part 2 that triangles ABN and ACM are congruent, we can easily notice that AN and AM are equal since they represent corresponding elements of these two congruent triangles. Also, we can prove it another way. We can also claim easily that angle ANM equals angle AMN because they both represent two corresponding elements in these two triangles, congruent triangles ABN and ACM that we just proved that they are congruent. You can choose either method. So AN equals AM, corresponding elements of these two congruent triangles, and as a result, triangle MAN is isosceles of vertex A since it has two equal sides, AM and AM. So proof: AN equals AM, corresponding elements of congruent triangles ABN and ACM. Also, we can notice that also these two segments are sides of these two congruent triangles ANC and ABM also. So we can also write corresponding elements of congruent triangles ANC and ABM. It's the same. So result: AMN is an isosceles triangle of vertex A because it has two equal sides, AN equals AM. This is the end of the exercise and of our video. After watching the correction, I would like to ask you to copy the solution on your math copybook. And thank you for watching.